Hello, geometry class, and welcome back to our asynchronous class time on this beautiful sunny day. First thing I'm going to tell you is get outside and do something fun outside today. Go for a walk, go ride your bike, go for a run, go play a game, go do something, go to a park. I don't know what, but get outside today, the rest of this week. Find some time to get outside, okay? So we're going to do a quick lesson today on two topics. The first one is called side angle inequality. Now you're going to need your notebook, and most of you did a great job last time on notes, taking some really good organized notes, making sure that they were legible, snapping a picture of those and uploading those. You're going to do that again today for your grade. So for today. So I want to make sure that you are aware of that. You want to make sure that you have your notebook ready, a pencil. You are going to need a straight edge today. You're going to need to be able to measure angles and side lengths. So you'll need a protractor, and then you're also going to need like a ruler if that's on the side of your straight edge, or it might be on the side of your protractor. So starting off, put down the title, Side Angle Inequality. That's what we're working on today. And here is our first investigation. I want you to draw a scaling triangle of any size and any shape. This whole activity should not take more than 5 minutes, even with the explanation. You're going to draw a scaling triangle. Remember, a scaling triangle has all three sides have different side lengths. Make it not too small because you want to be able to write on it and put some information on it. So draw a scaling triangle. All three sides of the triangle are different lengths. You're going to use a protractor and a ruler, and you're going to measure each angle in your triangle and write it down. And then you're going to measure each side of your triangle and write that down. And you can measure it in millimeters, centimeters, inches, depending on how big your triangle is and whatever units make sense to you. Just make sure that you're consistent with those units for the side lengths. Once you've done that, I want you to identify the longest and the shortest sides and the largest and the smallest angles. You'll need to pause the video because I'm going to go ahead to my solution for what mine was. So you'll need to pause the video while you do all of that and then unpause to come back to the solution. So you can see on my triangle, what I did was I measured in my side lengths. And so you can see that I have 170 meters right here from B to C. And I named my triangle A, B, and C. It's just going to make it easier for me to talk about it. So I measured this 170 millimeters. From A to C, measured 210 millimeters. And then from A to B, measured 80 millimeters. Then I measured all my angles, and I was trying to be as accurate as possible. Remember, they need to add to be 180. So if yours added to 179 or 181, that's close enough. So measure of angle A was 50 degrees. My measure of angle B was 107, and my measure of angle C was 23. And then you can see here I was listing my longest side and my shortest side. So when I think about my longest side of my triangle, my longest side was the 210. And my largest angle was my 107 degrees. So that's this one right here, this one right here. So notice that that was angle B and then also side B or AC there. My shortest side that I had was 80 millimeters right here. And my smallest angle was 23. Notice that that was angle C and side C or length AB. And so if I were going to order these, then I could see that it looks like my smallest angle is going to be opposite my smallest side length. My largest angle is going to be opposite my largest side length, and vice versa. I could switch that around. If I said that my largest side is going to be opposite my largest angle. So if I'm given the side length, I can find the largest angle or smallest angle. If I'm given the angle, I can find the longest or shortest side length. So our side angle inequality conjecture, you do need to write this down. So in your notebook, you should have that scalene triangle. You should have all of those things written down that are just like mine. And now you're going to write down this conjecture. In a triangle, if one side is longer than the other side, then the angle opposite the longer side is the largest angle. Whoops. Let's get rid of that. Y'all know I've got this little button on my pen and it's hard to not push that button. So is the largest angle. And I have a little bit more information on the next slide. So on this one, if one side is longer than the other side, and then the angle opposite the longer side is larger than the angles. So it's opposite the shorter sides. So what we typically do here is we draw arrows like from the angle to the side and the angle to the side to show where they are going with that. So when we look at that, for this example that I have here, this is 77 degrees, 70 degrees, and 35 degrees. And if I wanted to list these from large to small, I would start with my 77 degrees, then 70 degrees, and then 35. And now I can list my side lengths from large to small. So opposite 77 is side A, opposite 70 is side B, and opposite 30 should be 33, not 35. 33 is side C. Yesterday in our worksheet, questions 4, 5, and 6, those were ones I told you to skip. It was because they were all about this. So you could go back and try questions 4, 5, and 6 and see how you do on those on that worksheet. The second thing we're going to talk about today is the triangle exterior angle conjecture. This one goes along with question number 10 that was on your worksheet that I said we haven't talked about that yet. So in your notebook, write down the title, Triangle Exterior Angle Conjecture. And then I want you to draw this image. So you're going to draw a triangle, but notice that this one side is extending out. So it's a ray and it's extending out. And we're going to mark these different parts on your triangle. So the exterior angle is this part right here that's extending out from that ray. And everything is going to be kind of centered around this, like how we name it, it's going to be based off of that. So this is our exterior angle. Then this angle that makes the linear pair or that's supplementary to that is our adjacent interior angle. Adjacent just means next to, and interior is inside. So it's next to the exterior angle, but it's inside, so it's interior. Adjacent, interior. And then the other two angles down here, in this case B and C, these are the remote interior angles. Again, interior is inside, and remote, they're not right next to, they're a little farther away. So B and C are the remote interior angles. Make sure you have that drawn and everything labeled on it in your notes. And then you're going to open your textbook up to page 217 to 218. For this investigation, you're going to need a straight edge and you're going to need some patty paper. You're going to start off, follow the directions, and you will put this in with your notes too. So I want to see this investigation. You will draw a scalene triangle for this investigation. Again, we're not in groups because we're in distance learning, so don't worry about the each person part. So you're going to draw a scalene triangle. You're going to name it ABC, and you will extend ray AB beyond point B. So you can see the picture that they've drawn here. So you'll draw one similar to that. But again, make sure that it's a scalene triangle, not equilateral or isosceles. Okay. label a point D outside of the triangle on ray AB and label the angles as shown. So you can see that there's A and C here. Clear that so we can see that better. So A and C, and then B here, and then X for that angle. Now what you're going to do with your patty paper, so this is in your paper on your notebook. So this first part right here, this is in your notebook. Then you're going to do this copy, the two remote interior angles, angles A and C. This is on patty paper, similar to this right here. So you're going to copy them together to show their sum, and then you're going to compare angles A and C with angle X. So you're going to take your patty paper and line it up on X and see what happens. And then step 4 is state your observations in a conjecture. So what did you notice? Maybe it's not a formal conjecture, but what did you notice with that? Once you have that done, go on to the next part. You may need to pause the video to complete all of that and then unpause to come back. And here we have our triangle exterior angle conjecture. So with this, it tells us the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So let's just label some things here. So we know that X is our exterior angle. A is our adjacent, remember next to, interior angle. And then B and C are our remote interior angles. And I'm just renaming those things or relabeling them so this makes sense to us. So the measure of the exterior angle, X, is equal to the sum of the measures of the remote interior angles, so B plus C. So you can add those two angles together and it will give you the measure of X. And now think about that. B plus C plus A will give you 180, right? And X plus A gives you 180. So let's think about if we had B plus C plus A, that equals 180. X plus A equals 180. And so then that means we have A and A here, right? And 180 and 180 here. That means B plus C has to be equal to X. So it makes sense, right? So for practice after this, I would like for you to go back to that worksheet from yesterday. Worksheet 4 goes 4.3. And I want you to do numbers 4, 5, 6, and 10. That's what I want you to finish up for today. So after you've done all these notes, go back to worksheet 4.3. If you need to unsubmit it, that's just fine. And I want you to try problems 4, 5, and 6. Number 6, that one's a little tricky. So I want you to work on it before you just give up and say, I can't do it, okay? Because it's a couple of triangles together, all right? Hope everybody's having a great day, and I will see you in live class on Thursday.